Section 4.6 has to do with isosceles triangles. Just a real quick reminder of what isosceles implies. You have a triangle that has a base and you have two legs that are congruent to each other. Isosceles triangle means that two of the sides are congruent. So this is the base that's not congruent to the other two sides, and then these two are considered legs because they are congruent to each other. On an isosceles triangle, you have some new theorems that can be used in proofs or in problems. Theorem 4.9 says angles opposite congruent sides are congruent. So if this and that are congruent, then I automatically know that the angle opposite that side, now that's angle A, would be opposite that side BC, which means if I stood on this side I couldn't touch angle B or I could touch them. The one angle that I could not touch standing on this side is angle A. So that is the angle that is opposite BC. So the angle that's opposite AB, the one across from it, is angle C. So based on this theorem, angles opposite congruent sides are congruent. So this side is congruent to that side, so this angle is opposite that side, and that angle is opposite that side, so those two angles are congruent to each other. So for say, if I went back to that illustration, if I have these two legs that are congruent, then I also know that those two angles are congruent. So that angle is opposite that leg, this angle is opposite that leg, so those two are congruent to each other. Theorem 4.10 says sides that are opposite congruent angles are congruent. So if I know that two angles are congruent, so A, B, C, if I know angle A is congruent to angle C, then I know that this side, because it's opposite that angle, is congruent to that side because it's opposite that angle. So sides opposite congruent angles are congruent. Then you have two corollaries. A triangle is an equilateral if it's an equiangular. We've already talked about that. If it's equiangular, it's also equilateral. So if all the sides have the same measurement, then all the angles have the same measurement, and that angle measurement has to be 60. Because if you can remember, all of the angles in a triangle add up to 180, and the only way to do that is if they're all equal to 60 for them to be equal to each other. But that also implies that the sides opposite congruent triangles are congruent. So the side opposite that would have to be congruent to the side opposite that, which is congruent to the side opposite that. So an equiangular also makes it an equilateral, and an equilateral also makes it an equiangular. So then we're going to use these problems, these theorems, these corollaries, to do problems and proofs. So on this particular one, if I know that DE is congruent to CD, and I know that BC is congruent to AC, then I want to, and I know that angle CDE is 120. So I want to know the measure of BAC, which is that angle. So I know that this angle has to be congruent to that angle because those are angles opposite congruent sides. So I've got 120 that I'm taking away from 180. So 180 minus 120 is 60. I have 60 degrees that I need to distribute between those two. So each of those would be 30 degrees because they have to be equal to each other. So now if you added that all up, you would get your 180 degrees that you know you have with a triangle. So if this is 30, this is also 30, because those are vertical angles, and vertical angles are always congruent. And I come over here. Remember the whole thing about angles opposite congruent sides are congruent. So that angle has to be congruent with that angle because they are opposite congruent sides. So now I have my 180 minus my 30, because I already know that, which is going to give me 150 that I can divide between those two angles. So 150 divided by 2 is going to give me a 75. So each of these angles are equal to 75. So my answer here is 75 degrees because that's angle BAC. All right, now let's do a proof on these. I know this information. I've got an illustration, so I do my statement. I don't have to rewrite that because it's already written down for me. My reason. So step 1, of course, is to repeat all you're given. Notice it says equal and not congruent. Not that that matters, but it does in this particular thing. Then I have a congruency on this. ACB is congruent to BCD, and that is your given. Okay, I would go back and I would put congruency on here because I'm going to have to prove that these two triangles are congruent. So here I've got AB is congruent to CB, which is congruent to BD. I'm not going to have to do any math on it, so I want that congruency mark on it. And that's definition of congruent. Congruent just means they're equal. So I'm going to go AB is congruent to CB, which is congruent to BD. So all of those are congruent. I also know that angle ACB is congruent to angle BCD, so I know those. What I'm trying to prove is that angle is congruent to that angle. If you notice, I already have side, let's see, I've got the two sides and I've got two angles, so I can, let's see, I can prove other angles because I've got angles opposite congruent sides. So if you will, I know that this angle will have to be congruent to that angle. So that's going to be my next step, is that angle A is congruent to angle ACB, and at the same time I'm going to go angle D is congruent to angle BCD, and the reason is angles opposite congruent sides are congruent. That side and that side are congruent, so this angle and that angle have to be congruent. This and this are congruent, so that angle and this angle have to be congruent. So if you turn around and you go, I've got angle side here, so I can turn around and say I can substitute up here for these two. I can go angle A is congruent to angle D, and I just substitute into that congruency statement. So you've got this statement up here in the given, the angle ACB, which is that angle, is equal to angle A. BCD is equal to that angle, which is angle D. So I just substitute it in there. So I have substitution, and now I have angle angle, side. Okay, because they definitely have that in common, which I already knew that they had because that was congruent to that. But those two angles, that's congruent to itself, if you will. So there's a couple ways you could have done this, but I think that might be the easiest way. We'll go ahead and put that reflexive statement in there. So I have CB is congruent to CB. Oh, actually, I can stop here because that was all I was trying to prove. I don't need to prove the triangles. Sorry about that. Okay, so I'm done at that spot. Okay. All right, your homework on this is page 219 through 220, 10 through 28 even, and then 29 is a proof that I want you to try.